Hello students, today's topic is development of embryo. The process of development of zygote into an embryo is called as a embryogenesis. So embryogenesis is a process of development of zygote into embryo. So this embryo develops at the micropylar end of embryo sac. So the growth of embryo triggers after the certain amount of growth of endosperm in the embryo sac. So here is a first endosperms develop little amount and then embryo starts to develop. Okay, so this embryo starts to develop after the fertilization. So what is that fertilization? In this process what happens? Male gamete fuses with the egg cell and form the zygote, and that zygote undergoes the development from the embryo. So these kind of ways it occurs after the fertilization. The embryonic development begins. So this diagram we already studied in the double fertilization. This is again gynoecium, structure of gynoecium. Swollen part is the ovule. This embryo sac possesses the 3 antipodal cell at the chalazal end. Micropylar end shows the pollen tube which consists of 2 male gametes. One male gamete fuses with the egg cell and the other male gamete fuses with the endosperm and forms the PEN, primary endosperm nuclear cell. Now here is it forms the zygote. So this zygote converts into the embryo. This part, this cell converts into the embryo. So this is the diagram of anatropous ovule that we already studied. This part is we already studied. This embryo, development of embryo, the zygote divides into the 2 cell structure is called as a proembryo. So this 2 cell structure, the first 2 cell structure is called as a proembryo, but zygotes divide unequally and one cell becomes bigger and other cell becomes smaller. So the bigger cell at the micropylar end and smaller cell at the chalazal end, and this micropylar cell, towards the micropylar end, that cell is called as a suspensor. Okay, suspensor initial cell, which is also called as a basal cell. At the chalazal end is called as a terminal cell, which is also called as a embryonal initial cell. So there is a 2 cell structure is called as a proembryo, which consists of what that cells is called as a suspensor initial and embryonal initial cell. Okay, now here is a suspensor cell divides transversely in one plane and form a filamentous shape of a structure. That filaments consist of 6 to 10 cells. Now here I am going to show you the diagram. This is what oospore, that is what zygote. Zygote divides unequally, forms suspensor and embryonal cell. Suspensor divides transversely in one plane and forms the 6 to 10 cells in the filament. So this is the filamentous structure we observe. So this filamentous structure consists of 6 to 10 cells. Okay, it is observed in the suspensor. The first cell towards the micropylar is a swollen, little bit swollen comparatively the other cell, that is called as a hostorium, and at the chalazal end the terminal cell is it is a thinner and which is called as a hypocotyle. So these are the hypocotyle cell and this is the suspensor little bit swollen. So this suspensor or hostorium, this suspensor is very important because it pushing the embryo in the endosperm. So this suspensor push the embryo in the endosperm. So this kind of a structure we observe in the suspensor, division of the suspensor. Now here is a embryonal initial cell, it divides mitotically. It shows the 3 successive mitotic division and forms the octant shape. So this octant shape consists of the 8 cell. So this 8 cell, mass of 8 cell, that structure is a octant. Okay, so here is a 1 2 3 4 5 6 7 8. So this octant shape of a structure gets formed by the 3 successive division in the embryonal initial cell. Now here is a first, there is a lowermost 4 tier cell, 1 2 3 4. This lowermost 4 tier cell divides and forms hypocotyle and radical. So this lowermost cell forms the 4 lowermost cell forms the hypocotyle and radical, and this uppermost 4 cell, 1 2 3 4, these uppermost 4 cell tier forms the cotyledon and plumule. So this is the development of monocotyledon embryo. So up to the octant shape, this is the same in monocotyledon as well as in dicotyledon embryo. Okay, so this structure we observe both the monocotyledon and dicotyledon, but it gets differ further the division of the octant cells. So when the octant cells redivides, this shape gets changed in monocotyledon and dicotyledon seed. Now here is in the monocotyledon, this is again suspensor. Now this here is a lowermost 1 2 3 4. These 4 lowermost tier cell divides and forms the hypocotyle and radical. So here this 4 cell divides and redivides and forms the radical and hypocotyle, and there is a lowermost 4 cell divides and redivides. The mass of a cell forms the cotyledon and plumule. So this one is we can observe here suspensor becomes smaller, and this shows the larger growth of or mass of a cell. Now here we can easily make out a single cotyledon, then this is the plumule, and this one is a radical. If you observe this structure in the monocotyledon seed, this shield like structure is called as a scutellum. Okay, and this part, the covering, is called as a coleoptile. This coleoptile sheath covers the plumule, and this lowermost sheath, that is a coleorhiza, covers the radical. So this coleoptile and coleorhiza, these two sheath gets formed and forms a covering around the plumule and radical. Okay, so this kind of structure we observe in the monocotyledon, but in the dicot, here is the dicot. Again this one is a suspensor, we can easily make out this swollen part. Okay, now this uppermost cell, okay, this octant shape structure, the 1 2 3 4 cell gets divided again and forms a octant shape. So first 4 cell, this forms what? Cotyledon and plumule, and the lower 4 cell forms the radical and hypocotyle. So this first 4 cell divides and redivides and forms the heart shape. Here is gets divide. So this hypocotyle divides, redivides and form a large enlargement of the hypocotyle, forms the cotyledon in horseshoe shape. So due to the enlargement of the hypocotyle, this heart shape of a structure converts into the horseshoe shape structure. So this kind of a structure we observe in the dicot. So this is the dicot. This kind of a development we observe in the dicot embryo. So this becomes heart shape, then heart shape becomes horseshoe shape. So like these two becomes long cotyledons. So this is the development of embryo. So finally ovule is transformed into the seed and ovary into the fruit. So these kind of a structure we observe in the development of embryo. Thank you.